Hello, algebra students. Mr. Lawrence here with your flipped lesson, and we're going to do graphing from standard form today. We're going to quickly review the types of graphing we already know. Of course, this is called slope y-intercept, or just slope-intercept form. And when we have this, we know that we begin with our y-intercept, and then we do our movement or our slope. So I'm going to plot the point 0, 3, 1, 2, 3 right there. And then I'm going to use my slope of -1/4. So I'll rise -1 and run 1, 2, 3, 4. And that's rise -1, run 1, 2, 3, 4. Okay. Of course, I could have gone rise +1 and then run -1, 2, 3, 4. And I get my line. And of course, it looks something just like this, right? All right, that should be really basic. I expect you guys to be masters of that at this point. If you're not, you really need to come see me. That kind of thing should be simple. Okay, now you learned this new form over the weekend, and this was called point slope form. And remember, when we're here, our slope is still m, so that's still our slope. Now, just like in y-intercept form, we know a point, but we don't necessarily know the y-intercept. But the coordinates of the point would be x sub 1, y sub 1. And remember, they're actually the inverses because that's a negative there and that's a negative there, right? So we change the sign on y sub 1 and on x sub 1. Okay, so when I look at this equation here, y minus 4 equals 2 times the quantity of x plus 3. Well, I know my slope is 2 as a fraction 2 over 1. I know the point. I look for my x-coordinate right here. I change the sign, -3. I look for my y-coordinate right here. I change the sign, +4. Now, why is that helpful? Well, again, I can plot this point, -3, 1, 2, 3, +4, 1, 2, 3, 4. Okay, and then from there, I'll use my slope. I'll rise 2, run 1. Rise 2, run 1. I could go down 2, back 1 if I wanted. All right, and then I can do my line. Rise 2, run 1. It's going to look something like that. Put an arrowhead on the other end, and there we go. Okay, um, so those are the two types of graphing we've done so far, not counting, t-table graphing. Okay, well, there's the new form that you just learned about, standard form, right? That's what we call standard form. And remember that in standard form, we have the x term and the y term on the same side of the equation. The constant, the number without a variable, is over by itself. And then we always want a to be positive. Remember, a needs to be positive. Well, this is sometimes a very easy way to graph. And you remember back in our t-table days, I taught you initially to put 0 in for x. Go ahead and do that. You should be able to tell that if x is 0, this disappears, and I'm left with -5y equals 20. If I solve for y, I should get -4. 0, -4 is on my graph. 0, 1, 2, 3, 4, right there. Okay. And then I said an easy thing to do, way to cheat, would be to put 0 in for y. That turns this to 0. I have 4x equals 20. It must be 5. That point is also on the graph. 1, 2, 3, 4, 5. This is called graphing by intercepts, and I like to do it when I do standard form. It makes it really simple. So let me see here. Oops, hold on 1 second. Okay, so I can draw my line, and I'm going to point one thing out for you, like I said. Okay, let me see here. 1, 2, 3, 4, and over 5. So 1, 2, 3, 4, and over 5. Notice I used my slope, right? Okay, and let me put an arrowhead on that other end there. My slope, you saw me count, was 4/5. Okay, check this out. There's a 4 there and a negative 5 there. Huh. I wonder if I could get my slope by taking the A, putting it over the B. Well, it almost matches. It almost matches. If I change the sign, I get it. A shortcut the honors kids could tell you is to use negative A over B to get your slope. Okay, negative A over B. Take the coefficient on x, change its sign, put it over B. So A is 4, right? B is negative 5. So I take the coefficient of A, change its sign, put it over B, and the two negatives cancel each other out. Just ask Ashley Leonard. She asked about that on Friday during class. All right, let's try it with this one. Okay, I'm going to use a t-table to get my intercepts. Graphing by intercepts is easy to do. 0 in for x turns this to 0, right? I'm left with, here, let me see if I can cover that up. Oh, this will work nice. Okay, watch this. Shoop, shoop. Fill effects. We'll fill it with white, and we'll change the line to white, and voila, you can't see it. So we're left with equation 3y equals 12. Well, I know you're all so smart, you can tell me that y must be 4. So 0, 4, 1, 2, 3, 4 must be on my graph. Now I'm going to plug 0 in for y. Well, that changes things. That means that I need to cover that up. And so now my equation is 6x equals 12. Well, you guys can tell me that x must be 2. Come on, Kyle, you love doing things by the short method, right? So we're going to go 1, 2, and then 0. And there we go. Now, let me uncover things here. I'm going to draw my line. It looks like my slope is going to be 4 over 2, right? Or 2 over 1. So I'm going to go 1, 2, 3, 4, 1, 2, and there we go. Arrowhead, and that's it. Now let's check that little thing out. I'm going to get a slope of 1, 2, 3, 4, slope of negative 4 over 2, which simplifies to negative 2, or you could have said negative 2 over 1, right? Well, if I know that A is 6 and B is 3, then I can do negative 6 over 3, which simplifies to negative 2 over 1. So I can find the slope just by doing the negative A over B. All right, we're going to do one more example. We're going to try an ugly one like this, and this is actually really easy. Really easy. So we're going to do X and Y, and I don't think I have my circle anymore. I think I must have erased it. So I'm going to plug 0 in for X, and when I do that, I get the equation 1/2 y equals 1. Well, if I divide both sides by half, I get y equals 1 divided by 1/2, which is the same as 1 times 2. So therefore, 0, 2 is the point, the y-intercept. Right? We're dividing by a fraction. It's the same as multiplying by its reciprocal. Now I'm going to plug 0 in for y. And when I do that, my equation looks like this. 1/3 x equals 1. Well, if I divide each side by a third, I get x is equal to 1 divided by 1/3. And some of you are so smart, I know you can see that it's 1 times 3, which is 3. So the x-intercept is at 3, 0. 1, 2, 3. Okay. So I'm going to get one more, 2 more points on there. Looks like I went down 2, right 3, down 1, 2, 1, 2, 3. Some of you are probably wondering, why do I need to figure out the slope when I can just count it from the graph? My whole point in showing you this is that I want you to realize you can get the slope without graphing And there are some situations where it's just super smart to get the x-intercept and y-intercept. There's other situations where one of those intercepts isn't pretty. Well, if you could figure out the slope real simply, then it might be to your advantage to find out one of the intercepts, find the slope, and then rise and run to get your other points. Okay, so let's check it out here. We've got A is going to be equal to 1/3, and B is going to be equal to 1/2. If I take the negative of A, that'll be negative 1/3. I put that over B, that's 1/2. That's a division problem, right? So it's negative 1/3 divided by 1/2, which is the same as negative 1/3 times 2 over 1. Nothing will really cancel. I could cancel the 1's, but that doesn't do any good. I get a negative 2/3. And didn't I say my slope was down to right 3? It would be negative 2 over 3. Okay, that's your lesson for today. Mr. Lawrence signing off. Good night.